So let me explain how aliasing can be sorted out and resolved when rendering an image. So this is pretty much how anti-aliasing works in XSI. So we have two parameters in XSI, which is minimum and maximum. So even before starting, explaining what is minimum and maximum, I would like first just to explain what these value means. So let's assume that min and max are set to the same value. So in this case, if we do set the value to -2, it means that only one sample is going to be taken for every 16 pixels. So you can assume that for this particular setting, it's going to be very fast because it's skipping actual pixels. But obviously the actual quality is going to be very poor. So if, for example, we go to -1, then obviously we increase the density. So in this case, it's going to take one sample every 4 pixels. So it's skipping 4 times less information here in this case. So it's going to be rendered a little bit slower and will produce a little bit better quality, but not yet a production quality. So these two values could be more or less named more like infra-sampling or under-sampling. In the case where we set the value to 0, it means that every pixel is going to be sampled at least once. And so you can be sure that every pixel will be covered with this rendering. So again, the actual rendering quality just jumped slightly up. As you can see, going from -2 to -1 to -0, it simply increased the number of samples by 4 times. So here we go from 16 to 4, so it's 4 times less pixel being skipped. Here we go to 0. Now we're starting to break up the pixels into subpixels. So let's say, for example, we set the value to 1. It means that every pixel is going to be broken up into 4 subpixels. This is pretty much called super sampling, and that will produce a much better quality because now you're increasing the sampling rate. Same thing as the audio waveform. We're starting to get into the pixel and breaking the pixel up into smaller area to be able to render it. Again, if we go to anti-aliasing level 2, the number of sample per pixel subpixel is going to be 16. So we're really increasing the number of samples by 4 times. So we go 4 samples to 16. For example, we go to level 3 now. Then the number of subpixel for a given pixel is going to be 64. So every time we increase the anti-aliasing level by 1, we multiply by 4 the number of samples inside the pixel. So that has a fairly huge impact over rendering time because each of those particular sample has a cost. Usually they tend to be in milliseconds, but if you say I got 1 million sub-samples like this in a scene, then these milliseconds become seconds, minutes, even hours.